Are you using a serial flash or a standard EEPROM for your asset tracking device? Let me share the good news. I'm happy to introduce a new memory that combines the best of these two worlds, the Page EEPROM. The Page EEPROM offers enough storage and operates at a speed that facilitates firmware management. All this while tracking data over long periods and without wearing out the battery. Now, let's see the Page EEPROM in action. Imagine you have a fragile product that needs to be monitored. The temperature must be checked every second, and we must also detect any vibrations or faults. To make this happen, we need a memory that can regularly collect data, efficiently manage the firmware, and operate with ultra-low power consumption. Remember, our application is battery-powered. With this demo, I will show the impressive capabilities of the new Page EEPROM, including easy data logging, over-the-air firmware updates, and most importantly, its ultra-low power consumption. For the microcontroller and the sensors, the demo is based on the Blue Energy LPS, an ultra-low power programmable Bluetooth low energy wireless system on chip solution. For the external memory, we are using a 32 megabit Page EEPROM mounted over this X-Nucleo PGEEZ1. You will notice that the Page EEPROM is not just collecting data, it's also handling the firmware and its backup. And check out this display. You will see all the data captured in real time. Because every second counts, the Page EEPROM is constantly recording temperatures and detecting any faults. Now, here is why the Page EEPROM enables easy data logging. First, with 500K write cycles per page, the Page EEPROM can monitor 5 times more data compared to a serial flash. Your application becomes more accurate. Second point, you can update a byte directly, just like with a standard serial EEPROM. This means no complex software emulation or wear leveling needed. With this graph here, we can see all the values currently being monitored, including temperature and acceleration. Want to check if a fault has occurred? We can display the latest 1000 values stored in the Page EEPROM. This demo is just a short example of what you can monitor with the Page EEPROM. In this memory, we have successfully tested 1 billion cumulative write cycles. So besides these data points, you can collect much more data, such as GPS coordinates, humidity, pressure, battery levels, and much more. To recap, with the Page EEPROM, you can seamlessly manage intensive updates to ensure that your asset tracking device is exceptionally accurate. Now, let's zoom in on the over-the-air firmware updates. Currently, the firmware is executed in the flash embedded in the microcontroller, but the firmware and its backup are stored in the Page EEPROM. And when the application starts, the microcontroller downloads the firmware at 320 megabits per second thanks to the 80 MHz quad SPI interface of the Page EEPROM. With my phone, I'm going to update the firmware of the application. Consider a scenario where you want to update your application or add a new functionality. Imagine you need a wireless connection to update your firmware because you can't physically access the sensor. Here, we're using a Bluetooth connection, but this can be done using the Wi-Fi or any wireless connection. The application automatically receives the signals and prompts me to select the new firmware. This new firmware is in my phone but could be located in the cloud. I select my file and the photo begins. Okay, now let's see our Page EEPROM in action. We have the data logging storage area with the recorded temperature. The new firmware is programmed in the Page EEPROM before getting embedded in the microcontroller. The Page EEPROM is used as a buffer. We still have the golden backup in case the application needs to revert to the firmware version that was initially installed at the factory. with 100 years of retention associated with the error code correction, your firmware is completely safe in the Page EEPROM. During this FOTA, the application is on hold. Please keep in mind it is important to reduce this moment as much as possible. Thanks to a block erase time of just 4 milliseconds and a high-speed programming feature called buffer load, the Page EEPROM significantly reduces downtime during the FOTA process. If we go back to our graphical interface, we can see that we still have the temperature, but now the pressure is recorded as well. The new firmware is now monitoring the temperature and the pressure every second. In other words, we bring more value to the end user. So, we have intensive data logging, firmware management, but what about the Page EEPROM's power consumption? Page EEPROM versus a Serial Flash. Let's compare. Here, we've monitored the Page EEPROM and the Flash power consumption. The Serial Flash represents 5% of the application energy budget. The Page EEPROM only represents 0.5% of the application energy budget. Moreover, the Page EEPROM limits the current peak to 3 mA and enables longer battery lifespan. What does it mean? It means that the Page EEPROM significantly helps to lower the application's energy consumption, especially when the battery starts to wear out. Thank you for your attention. This demo is now over. Let's recap what we have learned. The Page EEPROM is an ideal choice for battery-powered applications that records data and require remote firmware updates. With bat-level access and higher endurance, you can monitor assets more frequently and boost the accuracy of your application. With firmware storage and ECC, your application remains reliable during critical operations such as FOTA or booting. Finally, with ultra-low power consumptions and peak current control, your application can last longer and use smaller batteries. I invite you to try the Page EEPROM. It is very easy to integrate. It is pin-to-pin compatible with Serial Flash, plus no wear-out leveling needed, and only a few software adjustments. You will find our new Page EEPROM in many power-sensitive applications such as hearing aids, IoT modules, smartwatches, and much more. I hope you enjoyed this demo. Visit our website st.com/PageEEPROM for more information. Thank you.